going ahead then. All right, lesson 5 begins with an equation. Our one variable equations tend to use x. You can use any variable that makes sense to you, but for the general form, we typically will use an x, okay? And we must define what that variable means. So don't just write down a variable willy-nilly like and then expect me to know what the heck you're talking about. Go ahead and tell me what it means. So if I write down an equation that says, let's go with 3x plus 5, okay? That's a one variable equation. Now, if I go ahead and tack on 11 to the end of that, I need an explanation for what x is, because right now this is just a string of numbers with a variable included, and it doesn't make much sense, right? If I tell you that x represents days, I can now start to formulate a story, and I may ask you to do this at some point. I'll give you an equation, tell you what the variable stands for, and then say, create a problem based off of this equation. So as an example of what I mean here, I would say, for each day, so each day meaning multiply, right? So for each day, you earn, let's say you do a small chore, $3 plus 5 per week. So this is your 5, saying that you've earned currently $11. You would be on day 2, okay? So for a small chore, let's say it's washing the dishes. Each day you wash the dishes, you get $3 plus $5 for doing it the entire week. So as a small bonus, there you go. So that might be the story that's included with this. You would make up anything that makes sense to you. Okay? All right, here we go. Linear equations. Linear equation, let's break down the word. Linear, L-I-N-E-A-R. Linear. Okay. This word starts with line. So I want you to underline it and then box it in. All right. Line is exactly what a linear equation is. So go ahead and write the word equation after linear. And we're going to draw a picture that goes with it. So a linear equation is just that. It is a equation that will produce a line on a graph. Okay? So an equation that when graphed makes a straight line. And if you want a picture of it, it's real simple. Just make an X and Y axis like this. Make sure you mark them with arrows, and then draw a straight line. Bam. Easy peasy. Okay. An equation that when graphed makes a straight line, period. We're going to use proper grammar here. We're having a problem with that. I'm looking at y'all's homework. You're not beginning with capital letters and ending with periods. Please focus on your grammar. Alright, so as we move down this, it starts to unfold into what a linear equation looks like. I guarantee you that every single linear equation will look like this in some way, shape, or form. You will see it like this. Y equals mx plus b. That's a linear equation. That's most of what you guys have seen so far. Y equals mx plus b is the most common linear equation that we will see. This is slope-intercept form. If you don't already know that, write her down. Slope-intercept form is a linear equation. Okay? So an equation with one variable, we're going to go back to my example, the 3x plus 5 equaling 11. That only has one letter in it. That's what it means, right? It only has one letter in it. So if I was going to get an answer for this, I worked it out. I got x equals 2. That's what I decided. And I need to check it. Okay? What we get at the end really matters here. I'm going to run a few scenarios just for giggles at the end. I'll run x equals 3. So for x equals 2, I'm going to go ahead and write down what I get when I do this. I just substitute in. This is substitution property of equality. So 3 multiplied by 2 plus 5 equals 11. This is not a check. until I finish working out the left side of this equation. So I get 6. 6 plus 5 is 11, and 11 obviously equals 11, right? No ifs, ands, or buts about it. 11 will always equal 11. So it works. It checks out. In the event that it does not work, for example, when we plug in 3, okay, I'm going to go ahead and plug in 3 over here, just slightly to the left of it. I get 3 multiplied by 3 plus 5 equals 11. Okay, again, 3 times 3 makes 9. 9 and 5 make 14, I heard from somebody. 14 equals 11. Never. Right? 14 equals 11, never, so it does not check out. I don't know why we have problems with this. So if you don't have a problem with this, let's just ignore this part of the thing. But I wanted to be clear that when you check it, if you get something that is not equal to each other, that means you did it wrong. Okay? So for x equals 3, 14 cannot equal 11, therefore it is not a solution to the problem. Our answer was this one here. Alright. Let's see if we can do something a little more real world. Jump down to the very bottom of that page where it says understand. I'll read it aloud real quick. Many real-world solutions can be modeled by using linear equations. Linear equations can often be used to model situations that involve a constant rate. On y equals mx plus b, m is the rate of change. It is the slope, right? So, a constant rate. For example, a plane flying at a constant rate of speed, 600 miles per hour, covers a distance of 600x miles in x hours. So they decided that x equals hours. So I'll go ahead and write that down because they're going to give me that equation, right? They said 600x, right there. And then they gave it to us. The time it takes, we need to find the time that it takes to fly 2,000 miles. And we're going to solve this equation. So if it flies at 600 miles per hour, this is x as in hours, and we need to fly 2,000 miles, we're going to solve that problem. What do? How do I get a multiplication problem to get rid of a coefficient? Heard somebody kind of mumble it. Cambry, what is the answer to that problem? Why is it called? Canberra.
What? Division?
Well, yeah, what's the property? Yes, Cambry, it is the division property of equality. Anytime you do something to both sides, it is always whatever that operation is. Here it is division, and then you add property of equality to the end. It is not hard unless you make it that way. Alright, so 600 divided by 600 basically makes that go away because 600 divided by 600 is 1, and 1 times x is x. Now, this one is 2,000 divided by 600. I just happened to notice that the 20 divided by 6 will get rid of these zeros, so I'm just going to go ahead and do that 20 divided by 6. What do I get when I divide? 3.3? You sure? I'm feeling silly right now. I hope you're right, because I enjoy being wrong. You're probably right. 3.3, good. 3.3, repeat end, right? So about 3 1/3 hours. What is a third of an hour in minutes? What is a third of an hour in minutes? It's 20, right? All I do is take 60, multiply it by 1/3, or just divide it by 3, whatever you want to do. You're going to get the same exact answer. So it'd be about 3 hours and 20 minutes, right? So to answer this question, because it asks for it in hours, we would say 3.3 repeat end hours. Now, just for clarification, if you wrote this down on a quiz, test, whatever it is that you were writing this down on, and you did not put the repeat end over it, and it asked for an exact answer, you are wrong. 3.3 and 3.3 repeating are not the same thing. You must put the repeat end if it wants an exact answer. Okay? Alright, flip page, go to the next one. Alright. It says the sum of two consecutive even numbers is 110. What are the two numbers? Now, you've probably not heard a problem like this before, so I want to be clear. When I'm talking about an even number, what is the difference between two consecutive even numbers? For example, 4 and 6. What is the difference between 4 and 6, guys? Not a hard problem. 2, right? So, if I wanted to go from an even number to the next even number, what would I do? I would take that last even number and do what to it? Oh no. Okay, let's run the example. We start at 2. What's my next even number? 4. What did I add to it? 2. So I have to add 2 to get to the next even number. So if they're talking about two consecutive even numbers, we have an even number, and its next even number is that last even number plus 2. So if my first even number was 10, my next even number was? Guys, that's for you. 12. Thank you. Okay, so to answer the question, it says the sum of two consecutive meaning one right after the other, even numbers is 110. What are the two numbers? So here's the number, here's its next even number, and it said the sum, so we're adding them together, and then it said it was going to be equal to 110. I need to solve this. How do I do so? He says subtract 2. I'm not going to disagree. That's not what I would do first, but I'm not going to disagree. Subtract 2 from where? We'll go to that step next. Now that you've already said subtract 2, we're going to go that direction. So what do we subtract 2 to? We do it to both sides by what property, Cambry? Subtraction. P-O-E. Good. All right, so that's gone. I'm left with 108 on my right, and I have n plus n. Now, Tice says to do what? No, what Tice said to do a second ago. What did Tice say to do? Not what is the answer. He said combine variables, right? He said to combine the variables. Make sure you're listening to the question. He said to combine variables. Now, I could have combined before in that first step. That would have been fine too. You're not going to be wrong. So when I combine n and n, I now have two n's. Really, that's just 1 plus 1, right? So now that I've combined my variables, that would be what I would write on my justification if I was justifying this. I need to get rid of this 2 because I need to isolate the variable. You're going to hear that a lot. Isolate it. I must divide by using the property of equality that is called division. P-O-E. So 108 divided by 2 gives me what? 54. Circle my answer.
So n equals 54.
N equals 54. Any questions, comments, concerns there? There is a very interesting problem to solve on the next page. So go there. This is an exponential equation. Okay, first one we had was a linear equation. It dealt with things that just had one variable in them and nothing else on that variable. This one will have some kind of exponent to deal with. Now, this is how you normally see them. They'll give you a problem. So here's your two examples. You'll have, let's say, 6 to a variable. So 6 to the x power. And they'll say, find the answer to that problem. Okay? So that's your first type of exponential equation. The second type of exponential equation is they'll give you a variable to a power and then ask you to solve for it as well. Okay? Now there's several ways that I guess you could go about solving these. Yes, sir.
On the first one, you put like find the square root, find the
6. Oh, okay, I see what you're doing. Yeah, you could. It's not the 6th root for this one, though. It would be for this one. So you'd ask, this is for Tice. If you don't understand what we're talking about, just ignore it for a second. On this one, you would say the 4th root, because it is to the 4th power. But here, you're not asking what is multiplied by itself 6 times. Because root asks what multiplied by itself. And this says something multiplied by itself 4 times. Alright, so going back, to solve these, for the time being, because we don't have the stuff in our toolbox yet to solve these for the time being. It is going to be a little bit of guesswork, okay? So you're going to say, all right, so if I go 6 to the 1 power, well, that's just 6. Clearly, that's not 216. If I go 6 to the 2nd power, that's 36. That's not 216. If I go 6 to the 3rd power, I'm going to get what? Type it in, guys. 6 to the 3rd power. What am I going to get?
108.
That's a good guess.
No, it's not. All I do is. It's 216. That's what
216.
That's not what you said.
You're funny, kid. Okay, so basically we just do a bunch of plug-in checks. So on my, if I was going to do a plug-in check chart, this is exactly what it would look like. I put X in one, and then I'd get my answer in the other. So I'd plug in 1, 2, 3, and then I'd continue down until I got the answer. So when I plug in 1, I just get 6. When I plug in 2, I get 36. When I plug in 3, I get 216. And 216 is my answer, so I know X is equal to 3. Okay, so that's what I would do. I'd plug in numbers till they made sense. Now, on this one, Tyce had a way to do it, and he said you can do it on your calculator. Okay, so I'll let him teach y'all guys how to do that here in a little bit. In a little bit. Okay, so if you're doing a plug-in check here, okay, we're doing a plug-in check. I want to think about what multiplied by itself, because that's what this question asks. What multiplied by itself 4 times is 212. So, Will, what does this question ask? You can just repeat what I just said. That'd be fine. Might want to pay attention, but okay. This problem says what number, X, multiplied by itself 4 times is 212. So what did I say that time, Will?
Why do you catch me when I'm asking a question?
I asked you a question. Twice now. Okay, I'm going to say it for the 5th time. This time I want you to repeat it back to me. I got it? What number multiplied by itself 4 times
Multiplied by itself 4 times.
is 212? All right, so what does this problem ask?
What number multiplied by itself 4 times 212?
Okay, so I would run this scenario just the same way as I did the last one. I just make a chart. 1, 2, 3, 4, and I just continue it down. So 1 times 1 times 1 times 1 is always going to be 1. 2 times 2 is 4, and then I could just say 4 times 4, because that'd be 16. 3 times 3 is 9, 9 times 9, 81. 4 times 4, 16. 16 times 16. Say what? I can do 16 times 4, sure. 16 times 4 is 64.
256.
256, right? So 4 to the 4th power is 256. Is anybody seeing a problem between 3 and 4? There's a big difference, and neither one of them are 212. So now we need Tice's method. So Tice is going to come over here. He's going to show you his method on the calculator. We're going to see if we can see it. Hopefully we can. He said he noticed that this problem asked something to the 4th power. In other words, he found that the opposite of the 4th power is the 4th root. He's going to show you how to do it on the calculator. Hopefully he's right.
So, okay.
I've never seen him do this.
Alright, so you're going to type in 4, then press second and square root, and then 212. Right?
I don't know yet. I haven't seen him do it. Go ahead and press it.
Alright, here we go.
No, that's way too big.
That's like 58.
Yeah, that's a big number. I know what you're trying to do. I've seen it on little calculators. I've never seen one of these. Let me see if I can find it real quick.
I was fixing it up from
Alright,
Good
so
morning, I'm Mr. Delk. I will be your teacher person.
if you go to math on your calculators, you type math, you're going to go down to number 5. Number 5 has a square root with an X where he's trying to put it. Press enter on that.
Then
Okay.
press 212.
So you would
Oh,
type
but that's
in.
his answer.
So let's start from the beginning. You type in 4. Go back. You
So
type in
4.
4 because that's what the power was. And then you go to math.
Math. Down to
down
5.
to number 5, which was the square root with an X on it.
Right.
Go ahead.
This one.
212, right?
Yep, then we're putting in 212. That's really hard.
Alright.
Know that it's there. Alright, press enter.
Enter.
So now that we have to the 4th power there. We're going to go ahead and type in 212. Hopefully this works. Go.
And it's gonna work.
3.81. That is a decimal approximation to 8 decimal places, okay? So know that that is not an exact answer, but that is as close as we can get. And if we look at our chart here, it was easy to see that it was going to be between 3 and 4. Thank you, Tess. It was easy to see it was going to be between 3 and 4. Tess just tried to dab and it didn't work, so. It was easy to see that it was going to be between 3 and 4. We just didn't know whether it was going to be closer to 4, closer to 3, and by how much. So the real answer to this equation is much more complicated than it originally turned out to be. So plugging and guessing wasn't going to work here because I don't guess that you're going to plug 3.81 something, 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 right? Nobody's that dedicated to this cost. So, oh, you go, kiddo. All right, so let's go into some, hopefully, answering problems here. Here is the equation that we need to get done. 4 multiplied by 2 to the 2x power plus 1 equals 17. I imagine this is something to do with an exponential growth equation. So,
Wait a minute.
yes, sir.
Is that 2 to the second?
2 to the 2x power. Yep.
That is cool.
2 to the 2x power. All right, here we go. Let's start by ignoring this completely. Know that it's there, but we're not doing anything with it. We got to get rid of the stuff around it. So I told you guys there is nothing there right now because we're ignoring it
But we need to
for the time being. It's in the book.
I figured it out, Coach.
It's in your iPad then.
Coach, I figured it out.
All right, so we're going to solve this. I'm going to just put this yellow Post-it note over that, right, for the time being. We're going to solve for this yellow Post-it note. I need to do order of operations backwards, so I'm looking for addition and subtraction. Well, I notice there's some addition and subtraction right here. So I need to get rid of that addition by subtracting it, do the opposite operation. So I've gotten rid of it. I now have 16 on this side, and it equals 4 multiplied by yellow Post-it note. Okay, so 4 multiplied by yellow Post-it note. How am I going to get rid of the 4 multiplied by? I'm going to divide it on both sides, right? So now I've got rid of my 4. I have now have a 16 divided by 4, which is 4. And on the left-hand side, I have yellow Post-it note. Now I'm going to replace yellow Post-it note with an actual number, and we know that yellow Post-it note was really just 2 to the 2x. I can start solving this problem now. So, if I know this answer, and Logan has already said that he found an answer, you sure it's right?
Yeah.
Okay, tell us how you did it.
Well, I did the same thing he did, and then I don't know. I just pretty much I don't know what to say. I don't want to say I divided. I don't know how to divide the exponent, but x is 1, obviously.
He says x is 1, obviously. Why is x1 obviously 1?
Silly.
No silly goose explanations here. Because 2 to the second power would be 4, so therefore the only thing multiplied by 2 that would still give you a 2 up here is going to be 1. So basically, this is what Logan did. I'm going to try to follow his mind processes here. So now it's 2 to the yellow Post-it note power. But he asked himself, well, what is 2 to the yellow Post-it note power, really? Right? So 2 to what power is 4, is what he asked. It's obviously 2 to the 2, right? So if 2x has to be 2, he said, well, the only thing that would fit there is 1. Well, obviously, right? Because if I divide it by 2 on both sides, the only thing that's going to give me that answer is 1. While I appreciate Logan's reasoning, we also have to be able to explain it to somebody else without saying it's obvious. Now, once I get my answer down, I circle it, and I would check it again. So I'd go right up here. I'd say 2 times 1 is 2. 2 to the 2 is 4. 4 times 4 is 16. 16 plus 1, 17. It checks out because 17 equals 17. Sorry, some things are hard, some things are easy. I don't know. Okay, so here's I know everybody's going, when am I going to use an exponential growth equation? We used one the other day for rabbits, which was just interesting. It wasn't necessarily useful for most of us, except for maybe Hope, who was going to have 16,000 rabbits in a year. But exponential growth goes to bacteria. We shouldn't be talking, we should be listening. Exponential growth goes to bacteria. So if you think about bacteria as in sicknesses, okay? So anybody in here know what the bubonic plague is?
Yeah.
Figured you would.
Yeah, I do.
Bubonic plague was a plague that struck pretty much everywhere a long, long time ago and killed millions and millions of people. Pretty much decimated the population of Europe, cut it in half. Because people got the bubonic plague from basically rats. Fleas. Plague.
From rats?
Yeah. It's fleas, but, I mean... Anyways, so these people got the bubonic plague, and in order to get rid of it, your body would just have to fight it off naturally. They didn't have like an immunity thing, like get shots. Anyways, it spread exponentially. So let's run a scenario. Sorry Mark, you're going to be the weakest link here. If Mark got the bubonic plague, and this group was his family,
I would give him my money.
high probability that they are going to die. And if Logan is friends with Will, and he got Will sick,
I'm going to kill you.
then the next week, his group is probably going to die. Y'all ain't got friends? So these are the three people who survived the bubonic plague. But unfortunately, they got to walk all out the same door. So a month later, because they continuously touched the same doors as the people that died from the bubonic plague, they once again, the rats came off the ships. That's how they got there.
Sealed with plastic.
With plastic.
I live in the mountains where
We
nobody
have a
can
greenhouse
reach
in my
me.
closet.
She will survive. You all will die from the bubonic plague. So, fun fact about the bubonic plague.
I don't even live in here.
Everybody know the song Ring Around the Rosie?
Yep, it's during that time of.
Written about the bubonic plague.
So like,
Ring Around the Rosie, pocket full of posy. You want to know why they kept their pockets full of posy? Posy is a flower. So they didn't smell the stench of rotting flesh.
I know, that song is just...
Ashes, ashes, because they burn the bodies to keep the bodies from spreading the bubonic plague more. They all fall down. They all die. It's a terrible song. And you teach this to children.